We have question 16. Question 16. The rate at which the body cools is proportional to the amount by which its temperature exceeds that of the surroundings. The body is placed in the room of the temperature. So we have the rate at which the body cools. That rate is proportional to the amount by which the temperature of the body exceeds that of the surroundings. So we are going to let capital T be the temperature of the body. So the rate at which the body cools, this is the temperature of the body, is proportional to the amount by which the temperature of the body exceeds that of the surroundings. Proportional to the amount by which the temperature of the body exceeds that of the surroundings. The body is placed in a room of temperature 25. So the temperature of the room is actually the surroundings. Yes, so the surroundings. So we have what do we have? We have the rate at which the body cools. So we shall have the T. This is the body temperature. So as this body temperature varies, so T over capital T is proportional. That rate is proportional. Is proportional to the amount by which the temperature is proportional to the amount by which its temperature, the temperature of the body, the temperature of the body is proportional to the amount by which the temperature of the body exceeds that of the surroundings. The amount by which, so it's just proportional to the amount by which the temperature exceeds. It's like if I say that the temperature of the body is 50 and the temperature of the surroundings, the temperature of the body is 50 and the temperature of the surroundings is 25. This is the body temperature. This is the temperature of the surroundings. So that rate is proportional to the amount by which this exceeds, proportional to the amount by which 50 exceeds 25. So you have to ask yourselves, by what amount does 50 exceed 25? By what amount is 50 greater than 25? By what amount is the body temperature exceeding the surrounding temperature? That is actually a subtraction. 50 minus 25, you get 25. Yeah. So here we shall have the temperature of the body exceeds the temperature of the surroundings by T minus 25. Observe that this is not T plus 25. No. So the body temperature exceeds the surrounding temperature by that difference. That is the required amount. You cannot say that 50, this is the body temperature. You cannot say that the body temperature, which is 50, exceeds 25 by 75. No. 50 does not exceed 25 by 75. No. 50 exceeds 25 by 25. Yeah. So we have that. Now we can deal with this. The rate at which the body cools. So the temperature of the body is decreasing. So to get rid of this proportion analytic, we are going to introduce a negative constant. We have that. Now we can solve this. Separate variables. We shall have dt over t minus 25 equals negative k dt. integrate. So if we integrate this side, we shall get natural logarithm t minus 25. This is equal to negative kt plus c. So this was our differential equation. We have solved this. So we have this. Part A, they wanted us to form a differential equation for the rate of cooling of the body. So we formed this equation. We have to proceed with solving it. Yes, with solving it. It does not just stop here. You proceed, solve it. How do you solve it? You get the value of k, this proportionality constant, also get the value of c, the constant for integration. So what else? Now we need to get the value of k and the value of c. So they have told us that after 6 minutes, the temperature of the body dropped from 90 to 60. So initially the temperature of the body was 90. So initially at t equals 0, at time t 0 minutes, we have our capital T as 90. That's 90. So we shall have natural logarithm capital T, which is 90 minus 25. This is equal to negative k times 0 plus c. So this implies that c is natural logarithm. Natural logarithm 90 minus 25, that is it 65? I think so. 65. So we can now substitute back the c. We shall have natural log t minus 25. This is equal to negative kt, and plus natural log 65. So after 6 minutes, so when t is equal to 6 minutes, after 6 minutes, we have our capital T as 60 degrees Celsius. So you substitute, we shall have natural logarithm 60 minus 25. This is equal to negative k times 6 plus natural logarithm 65. Natural logarithm 65. So you simplify, this is natural log 35 is equal to negative 6k then plus natural log 65. Natural log 65. So you bring this side. We shall have natural log 35 then minus natural log 65 is equal to negative 6k. So what does this imply? This implies that natural log 35 over 65 is equal to loss of logarithm is equal to negative 6k, implying that k is equal to negative 1 over 6, natural logarithm 35 over 65 over 65. We can actually reduce here. So what do we have? We have that as our value. Okay. You take note of the question. So that is our value of k. So we are going to proceed. So this is k. We can now substitute it back where? Substitute it back here. So we shall have natural logarithm. We substitute it back here. We shall have natural log t minus 25 t minus 25, this is equal to k negative, then times k, which is negative 1/6 natural log 35/65, then times t, so we have this multiplied with t, then plus natural log 65. So this is the same as natural log t minus 25. This is equal to t out of 6 natural logarithm. We are going to simplify 35 divided by 65. 35 divided by 65. That is 7/13. So this is 7/13, then plus natural logarithm 65. So we have this as our equation. So we got our differential equation, which is this, and we have actually solved it. So this marks the end of part A. That marks the end of part A. Part B, what do we have? Part B, we have find the time. So part B, they want find the time, find the time it takes, find the time it takes for the body, find the time it takes for the body to cool from 40 degrees Celsius to 30 degrees Celsius. Find the time it takes for the body to cool from 40 to 30. So what do we observe about that part B? So we have T1 as 40 degrees Celsius. Also have T2 as 30 degrees Celsius. So we are going to get the time corresponding to this and also the time corresponding to that. We subtract. We are going to substitute here. So if T is 40 degrees Celsius, substitute in natural log T minus 25 T over 6 natural logarithm 7/13 plus natural logarithm 65. So we shall have natural log 40 minus 25, 40 minus 25. This is equal to T out of 6. That is equal to T out of 6. Natural log 7/13 plus log 65. That's log 65. So if we subtract here, we get log 15, I think. Log 15. This is equal to T out of 6 log 7/13 and plus log 65 plus log 65. So bring this aside. We shall have log 15 minus log 65. This is equal to T over 6 log 7/13. So log 15 over 65 or 15 over 65 is equal to T over 6 log 7/13. Log 7/13. So we can make T a subject. So we have what? 6 log 15 over 65. This is equal to T log 7 over 13. So this implies that T is 6 log 15 over 65 over log 7 over 13. So T is equal to what? So T is what? T is what? We shall have 6 log 15 divided by 65, and this divided by log 7 divided by 13. Those are 14.21 minutes. 14.21 for the small places. 24 minutes. Yeah. Now we can proceed with the T equals 30 degrees. T equals 30 degrees. T equals 30 degrees. So if T equals 30 degrees Celsius, still we shall substitute here. We shall get natural log 30 minus 25 and minus 25. This is equal to T over 6. T over 6 log 7 over 13 plus log 65. So we get log 5 is equal to T over 6 natural logarithm 7 over 13 then plus log 65. Bring this side. So log 5 minus log 65 is equal to T over 6 log 7 over 13. What does this imply? This implies that we have log 5 over 65 is equal to T over 6 log 7 over 13. So we have 6 log 5 over 65 is equal to T log 7 over 13. 7 over 13. So this implies that if we make T the subject, this implies that T is equal to 6 log 5 over 65 divided by natural logarithm 7 over 13. So the value of T is what? We have 6 log 5 divided by 65 over so we have 24. T is 24.8606 minutes. Now we can subtract. So the required time is equal to 24.8606 and minus 14.2124. This is equal to minus 14.2124. This is 10.6482 minutes. So that is the time which is required for the body to cool from 40 to 30. Observe that as the temperature goes on decreasing, the time should actually increase. So when t is equal to 30, we should get a larger value of time as compared to the situation when t is 40. Yes. So the longer the time, the lesser the temperature. Yeah. And we cannot take the situation whereby we subtract 40 minus 30. Suppose we subtract 40 minus 30, we shall get 10 degrees. If we get 10 degrees Celsius and we substitute here, we shall not get the value of t, because here we shall be having 10 minus 25, which is negative, log negative answer, which is wrong. So we don't have negative logarithm. Yeah. So this is the proper approach of dealing with that question.